In previous videos, we learned that energy is the ability to do work or cause change. Doing work on an object means that the object moves because of a force being applied to it. We know that energy comes in two forms, kinetic and potential. Potential energy is stored energy, while kinetic energy is energy of motion. We also learned about three ways that energy can be stored. We talked about gravitational potential energy, we talked about chemical potential energy, and elastic potential energy. In this video, we're going to focus on gravitational potential energy. The amount of GPE stored in an object depends on three variables: the mass of the object, the acceleration due to gravity, and the height the object is off the ground. The larger the mass, the more GPE is stored, and the higher the acceleration due to gravity is, the more GPE is stored. But for our examples, the object's mass won't change, and all our examples will be on planet Earth. What will be changing is the height, and the higher the height, the more GPE is stored in the object. We also learned about kinetic energy. The amount of KE that a moving object has depends on two variables: the mass and velocity of the object. The larger the mass, the more KE the object has, but in our examples, the object's mass won't be changing. What will be changing is the velocity of the object, and the higher the velocity, the more KE the object has. There's a really important law that we must discuss. It is called the law of conservation of energy. It says that energy cannot be created or destroyed, but it can be transformed from one form to another. This law is the most important topic we will learn all year, because it applies to every topic we have learned and will learn about. It is the basis for science. What it means is there's a set amount of energy in a closed system, and energy can be converted, but it can't disappear or be created out of nowhere. We will focus on conversions between kinetic and potential energy. Let's look at an example of storing GPE in an object and have that stored energy turn into kinetic energy of motion and cause some damage when it hits something. Let's look at this again. As the height increases, more and more GPE is stored in the object. At the highest point, this is where the maximum GPE is. In this case, it is 100% GPE because the object is not moving. So there's no kinetic energy at all. Now what happens when the ball is released? It falls to the ground and causes change. Now there is an energy conversion happening here. As the object falls towards the ground, it is losing height, so it's losing GPE. But since energy cannot be created or destroyed, this energy must be converted into another form. But what is that form? Well, while the object is freely falling, it's gaining velocity and falling faster and faster towards the ground. So it's gaining kinetic energy. As the object falls, the GPE turns into KE. At the lowest point, this is where the maximum KE is, and the GPE is the lowest. Let's look at an object that does not drop straight down, but is thrown up and then falls down. Remember, energy cannot be created or destroyed, so the total energy cannot change. When first thrown, the energy is mostly kinetic energy, but there is still some gravitational potential energy because it is close to the ground but not touching the ground. As the object rises, the height is increasing, so it's gaining GPE. At the same time, it is slowing down, the velocity is decreasing, and it's losing KE. So on the way up, the GPE increases while the KE decreases, but the total energy is still the same. At the highest point, the object stops rising, so this is where the GPE is the highest. Since the object was thrown on a curve, it would still have some KE because it is still moving. As the object falls down, it is speeding up, so the KE increases. At the same time, the height is decreasing, so it is losing GPE. On the way down, the GPE gets converted into KE. When the ball reaches the same height as the starting height, the energy is mostly KE, but still has some GPE because it is still off the ground. The instant before the ball hits the ground, where the height is basically zero, all the GPE is gone and has been converted into kinetic energy of motion. This is where the ball is traveling the fastest. Let's take a look at a pendulum. At the highest point on the left, the pendulum has all gravitational potential energy. Once released, the pendulum bob starts to swing down to the right. You can see the energy conversion taking place on the graph on the left. But let's run this simulation in slow motion so we can really see what's happening. When the pendulum is released and swings to the right, it loses height but gains speed. So the GPE is being converted into KE of motion. The object speeds up until the lowest point. This is where the pendulum is moving the fastest. This is where the KE is the highest. After this point, the pendulum is rising and starts to slow down. This means the GPE is increasing while the KE is decreasing until the highest point on the right, where the pendulum bob stops and the energy has been converted entirely back into GPE. So any time that the pendulum is getting closer to the ground, it's losing GPE, but it's getting faster, so KE goes up. And then when rising, it's slowing down, so the KE decreases, but it's gaining height, so the GPE gets converted back. But remember, the total energy doesn't change. The real world doesn't act exactly like this because there's friction. As the pendulum bob moves through air, energy is lost to friction, sound, and vibrations, and the string rubs on the support. All of this means kinetic energy is converted into wasted energy like heat, so the pendulum won't actually reach the highest point on the other side, and eventually friction will steal all the energy away and the pendulum will come to a stop. The final example is the best example of energy conversions: roller coasters. All roller coasters work on the same basic principles. First, the roller coaster needs to get some initial energy to get the whole thing started. This can come from a motor or magnets. Second, have the riders experience a lot of thrilling accelerations by moving up and down hills, loops, spirals, and turns. Third, allow energy conversions between potential and kinetic energy to determine the speed of the coaster, but remember that energy cannot be created or destroyed. Finally, make sure that while the roller coaster is moving on the track, friction is reducing the kinetic energy, so at the end of the track, the roller coaster is coming to a stop. Brakes increase the frictional force a lot and make sure the coaster stops safely. For this roller coaster, a motor pulls the coaster up a tall hill and stores more and more GPE in the coaster as it rises higher and higher off the ground. At the highest point, the GPE is the highest. This stored energy is most likely enough to get the coaster to go the entire length of the track. But if it wasn't, there are probably additional motors along the track to give the coaster a boost. But that is energy from an outside source, so we will ignore that for this ride. As the coaster moves down the first hill, it is losing height, but gaining speed. That means the GPE is decreasing and the KE is increasing. You can see this on the bar graph on the left. At the lowest point, the GPE is the lowest and the KE is the greatest. This is where the coaster is moving the fastest. While rising up the loop, the GPE increases a little because the height increases a little, and the KE decreases a little because the speed decreases a little too. While moving down the loop, the GPE turns back into KE of motion. On the second hill, another energy conversion takes place on the way up the hill. The GPE is increasing while the KE decreases. And on the way down the hill, the GPE decreases and the KE increases. It's important to point out that the entire time, the total energy is not changing. That's the law of conservation of energy. Energy cannot be created or destroyed, but it can be transformed. In real life, friction and sound convert kinetic energy into wasted heat, or thermal energy. This means that by the end of the track, all of the kinetic energy has been converted into thermal energy and the roller coaster comes to a stop. Don't forget this law of conservation of energy. Energy cannot be created or destroyed, but can be transformed from one form to another, like from potential to kinetic.